Welcome to Air Academy Associates series on using SPC Excel. In this video clip, we will introduce you to the test of independence. The test of independence is for categorical variables. So exactly what is this test of independence? In this test, we are testing the relationship between two categorical variables. So it has to do with attribute data and counts. We do this by counting the number of elements from a sample that can be cross-classified by way of the categories defined by two different variables. For example, suppose we seek to determine whether there is an association or a relationship between gender and preference for flavor of ice cream. The two variables are gender and ice cream flavor. Gender has two categories, men and women. Ice cream flavor has three categories, chocolate, vanilla, and strawberry. Suppose this survey contacted 920 people and asked them for their preference of ice cream flavor. Here is the data from that survey, and this is the data that we would have to put into an Excel spreadsheet for the test of independence to take place. It does not matter if gender, men and women, went across the top when ice cream flavor went down the side. This is a 2 by 3 matrix, that is 2 rows by 3 columns. We could also have 3 rows, chocolate, vanilla, and strawberry, and 2 columns. The important point is to make sure the counts go in the correct cross-classification category. So when would we want to use this test? Anytime we want to investigate the relationship between two categorical variables and to see if two categorical variables are independent or dependent. Let's take a look at a couple of examples. For example, political party affiliation versus opinion on tax form. Are those two categorical variables related? In other words, is an opinion on tax reform related to party affiliation? Second one, product line versus type of defect. Do we think that the type of defect is dependent upon the product line? If so, we might conduct such a test. How about marital status and happiness? Is happiness dependent upon marital status? We can take sample data and we can find out. And the last one there that we will actually do here is a type of nicotine application. Is it by, I guess there's gum, there's inhalation, there's a patch. How is that related, if it is related at all, to the cessation of smoking? That is, quitting smoking or continuing to smoke. The hypothesis in this test of independence is set up as follows. The null hypothesis, H sub 0, in the population, the two categorical variables are independent. The alternative hypothesis states that in the population, the two categorical variables are not independent, they are dependent. Again, the burden of proof is always on H1. That is, we will assume independence until proven differently. Equivalently, these hypotheses can be set up as follows. H0, the null hypothesis, there is no relationship between the two categorical variables. And H1, there is a relationship between two categorical variables. So either one of these two hypothesis setups is deemed appropriate in a test of independence. I might say this before we go on, that when we conclude, if we were to conclude H1, that there is a relationship between the two categorical variables, that does not necessarily mean it's a causal relationship. There is a relationship, but the cause of that relationship may not be known at that particular time. Of course, we want to remember that the test of independence, like all of the hypothesis tests, is going to generate a p-value. Recall the rule of thumb for significance. If the p-value is less than 0.05, then we conclude there is a significant relationship between the two variables, and SPC Excel will print this p-value out in red. If the p-value is between 0.05 and 0.10, then there is a moderately significant relationship between the two categorical variables, and SPC Excel will print this value in blue. If the p-value is greater than 0.10, then we will conclude there is no significant relationship between the variables. That is, we cannot be at least 90% confident in H1. Recall the flip side of the p-value, and that's 1 minus the p-value. When we multiply that by 100%, we get the calculated percent confidence we have in concluding H1. Remember, low values for the p-value correlate to high confidence in H1. So the lower the value of the p-value, the more evidence there is pointing in the direction of H1. Now we're going to go to the software and we're going to look at a couple of examples. First of all, how you set it up in the software, and then how you interpret the test of independence results. The first example is going to have to do with 4 different hospitals in a healthcare system and the reason for readmission. That is, readmission rates can sometimes be higher than desired, and we're going to take a look at a fairly high sample. I think it's over 700 data points. So let's take a look at this example. In this example, we looked at 781 individual records from 4 different hospitals in a healthcare system, and we looked at the reason for readmission. And there were 3 categories under the reasons for readmission: premature discharge, patient lack of awareness, after discharge did not know who to contact, and the third category is ED decisions. That is, emergency department decisions. The 4 hospitals are down the side, so we have 4 rows and we have 3 columns in this setup. You can see the total there, 781, the subtotals of premature discharge and so forth. In other words, there were 125 patients from Hospital 1 that were deemed to have a premature discharge, and so forth. So you can see the cross classification here. We have 4 times 3, 4 rows, 3 columns, 12 numbers, and these are the numbers that we would have to garner to put into the software. Like I said before, the reasons for readmission can go down the side, the 4 hospitals can go across the top. It does not matter as long as we have the cross classification counts correct for each cell in the matrix. So we're going to do the independence test here, and we're going to highlight this data. If you have put the totals in, please do not highlight that, because the independence test will calculate the subtotals for each column and each row and then the total. So you do not want to put those in, because the software could interpret this 525, for example, as a number of premature discharge. So just put in this data right here, the 4x3 matrix, along with the labels, the column labels and the row labels. Now, you don't have to put the labels in, and you could just highlight this data right here. The independence test will still calculate a p-value, but you will not see the labels or the headings for each of the categories for the 2 variables involved. So put your data in, highlight the labels as well as the counts in each of the cells, and then come up here to Analysis Tools, where all of the hypothesis tests in SPSEQ-Cell are located, and click on Independence Test. Now it's going to come up and say, is this the data you want? We've already highlighted it, so we say OK, and out comes, let me blow that up a little bit higher, out comes a p-value. The p-value is a whopping 0.7301. So how do we interpret that? There is no significant difference here. In other words, there is not enough evidence to claim that there's a relationship between the reason for the readmission and the 4 different hospitals in this healthcare system. So not enough evidence here to conclude that there is a relationship between reason for readmission and the 4 hospitals in this particular healthcare system. A second example we'll look at is looking at the categorical variables called happiness and marital status. Let's check to see if there's any relationship between these 2 categorical variables. The data you see here on this Microsoft Excel spreadsheet comes from a very large sociological study that involved many variables, including marital status and a question on happiness. And you can see that the categories for marital status are married, widowed, divorced/separated, or never married. And happiness is not categorized on a scale of 1 to 10. It just says very happy, fairly happy, not too happy. This is a very large study, and this means that in this study there were 600 married folks who said they were very happy. And you can see that this is a 3-row by 4-column matrix, and we just highlight the data here. I don't have the subtotals calculated on this table, but the subtotals and the total will come out in the test for independence. So we go to Analysis Tools and we just call Independence Test Matrix up and we say OK. And in this case, let me blow that up, we're looking at the p-value, and it is significant. That is, the p-value is 0.0000, so we can be over 99.9% confident that the relationship between marital status and happiness is very, very strong, and we can be extremely confident of that based on the data from this very huge sample. Let me move that over so you can see the 3 categories under happiness: very happy, fairly happy, not too happy. Now the numbers in this table, let me just say a few things. These are intermediate calculations that are needed to calculate the p-value. Actually, what is happening is a chi-square goodness of fit test here. That is a chi-square test, I'm sorry. That's what the CHI stands for, the chi. There are numbers here that are a result of comparing the actual number of counts that we saw in a particular cell with the expected number of counts that we would get under the assumption that the null hypothesis is true. That is, we have independence between the marital status and the happiness category. So these numbers right here are just a measure of the difference between actual and expected, and the sum of these numbers right here, let me highlight this in yellow, and let me highlight these guys in yellow, and the sum of these guys. These are just intermediate calculations. The sum of those 12 numbers is equal to 224. That's called the chi-square test statistic, and the bigger that number is, the smaller the p-value is. Well, the p-value is extremely small because the differences between what we'd expect to see if these 2 variables were independent and what we actually saw are grossly different. That leads to a small p-value and a huge, highly confident conclusion in H1. A third example that we will look at is to evaluate the relationship between type of nicotine application and the ability to stop smoking or not stop smoking. So let's take a look at this data. In this example, the type of nicotine application had 3 different categories: the nicotine gum, the nicotine patch, and the nicotine inhaler. And the variable for cessation of smoking was either they stopped smoking or they were still smoking. So we highlight this data. We don't have the subtotals here. Of course, the independence test will calculate that. This is so easy. The hard part is getting the data. Once you've got the data set up like this, it's very easy. You just go to the independence test and out comes the matrix again. In this case, we're looking at a p-value. It looks like a 0.2240. Now, what does that interpretation mean of that particular p-value? It means that there is no significant relationship here between the type of nicotine application, whether it's gum, patch, or an inhaler, and the resulting cessation, whether they stopped smoking or they were still smoking. Not a significant relationship here. The last example we'll address here is concerning the effect of a cholesterol medication that is a side effect, whether we have abdominal pain or we don't. So we're going to check to see if the cholesterol medication in this case is related to abdominal pain. This data comes from a Merck clinical trial on Zocor. Merck manufactures Zocor. It's a medication I'm personally on, so I was interested in this study, so I went out and took a look at it. And the type of medication is one of the variables, and the side effect called abdominal pain, we either have it or we don't have it, is a second variable. You can see that the three categories of type of medication are Zocor itself, some placebo, and another cholesterol medication on the market at the time was cholestyramine, and they wanted to compare Zocor with a placebo with cholestyramine to see if the side effect of Zocor could be related to the other two and see if there is a relationship here. So we're going to highlight this data right here, not the subtotals, because the software will give us the subtotals. This is a study of pretty big, almost 2,000 individuals involved in this clinical trial. So we're taking a look at this data right here. I want to highlight the labels here, as well as the individual 6 cells. This is a 2x3 matrix. We go to Analysis Tools. We look on the Independence Test matrix. That's our data, and out comes, believe it or not, a very significant, highly significant p-value. 0.006 means we can be about 99.94% confident that there is a relationship between this cholesterol medication and the pain, the abdominal pain, whether we have it or we don't have it on the left-hand side. So there are 6 cells here, a very high test statistic, a very low p-value, indicating that we do have a significant difference here. I just want to point out, if you take a look at these values right here that I'm going to highlight in yellow, when you do have a significant result, as we do here, like a very small p-value, you might want to go check out where that's coming from. It's coming from this value right there. The 12.83 is the major contributor to this large value called the chi-square test statistic, which creates that small p-value. The bigger the test statistic, the smaller the p-value. And this is the primary contributor. Well, where's that coming from? It's coming from cholestyramine. And notice that the difference here, according to the null hypothesis, we'd expect 6.7 in here, and we actually saw 16. So that huge difference there is contributing to this number, and it's that guy that's making the difference. So let's say Zocor, or Merck in this case, wanted to look at a placebo. You could just take part of this particular trial here. Let's take a look at the values again on the trials, and just look at Zocor with the placebo to see if there's any significant difference between that. Certainly there's a difference between Zocor and cholestyramine, but how about Zocor and the placebo? Notice that the majority of the individuals in this study were taking Zocor, okay? But they had to put in enough samples for placebo and cholestyramine to make a reasonable comparison here. But we can cut this off and just do the 2x2 here, and we'll get the independence test here just between Zocor and the placebo. Let me blow this up a little bit, and guess what? The p-value is huge, 0.98. There is no significant difference between Zocor and the placebo. Now, when we cut off the cholestyramine and used only 2 columns and 2 rows here in the matrix, what we were doing is essentially a test of proportions. So when your independence test matrix comes down to a 2x2, it is equivalent to a test of proportions. Now, what is a test of proportions? If you remember, if we go up here and we go to a test of proportions, we will see that we have to put in 4 numbers. Well, what are those 4 numbers here? Okay, if we go to our Zocor and placebo, it's going to be a 51, which is the number having abdominal pain from Zocor, over a total of 1583. Remember, we need a numerator and a denominator. The total number taking Zocor was 1583, of which 51 have, let me put that in there again, have abdominal pain. And for the placebo, it's 5. divided by 157. You know what I'm going to do? I'm just going to copy those 4 values and I'm going to paste it in the test of proportions area right here. And let's paste it and look at the p-value there. So the test of proportions is 0.98, just like the independence test matrix got a 0.98 p-value. So when your comparison of 2 categorical variables reduces down to a 2x2 independence test matrix such as this one, the independence test and the test of proportions will provide the same p-value. Thank you very much for watching. This is the importance of an independence test, very powerful stuff that you can use when comparing any 2 categorical variables.